Okay, so our review for summative number 9 is a little lengthy. There's a lot of examples of the same kind of questions. So in this video, I'm just going to go over like an example or two of each kind, and then I'm going to leave some extra ones for you to practice. I believe the answer key is attached to the back of your review packet, so make sure you're out checking all your answers you're getting. There's no work on the answer key, so make sure if you have questions you come in before your summative. So this first section is a retake on the completing the square section. So last test we saw us solving by completing the square. All of your examples that we've had on the tests, and it will continue to be this way, have a coefficient of 1. So you don't have to divide by anything, but we do have to remember that the existing constant needs to move out of the way basically. So we're going to move the constant over to the other side, and when we go to rewrite this, we're going to leave a blank here so we can complete the square on that quadratic. Remember you add the 40 over here, so that's now a positive 40. But to keep your equation balanced, whatever you add into this blank, you have to add on the other side of the equation as well. So remember the c value, or the blank, is whatever your b term is, cut in half, and then squared. So this is your b value right there. So negative 18 cut in half is negative 9, and then negative 9 squared is positive 81. Okay, pen. Oh, it's going to be one of those days, I think. There we go, positive 81. So you're adding 81 to both sides of the equation. And here's why we did that. You just completed the square on this quadratic. So this quadratic factors into k minus 9 times another k minus 9. So the way we shorthand that is we write k minus 9 quantity squared. A few of you had the right idea for the factoring pattern here, except you lost your sign. Remember, it's got to be the same sign as the b term here. So it's k minus 9 quantity squared equals, let's see, that's 121. So this is an example where when you square root both sides, you're going to get k minus 9 equals positive and negative. Now square root of 121 simplifies down to an 11. So my work's going to run out of space here. If you go ahead and add the 9 to the other side and you write 9 and then you add and subtract 11, that's not going to be a good enough answer for us guys. So 9 plus 11 is 20. And then 9 minus 11 is negative 2. So if your answers boil down all the way to integers, I want you to go ahead and give me the 2 integer answers. Or even fractions if that's the case. But that's not usually the case for these questions. Let's take a look at number 3. I think we have some time here. We can do another example. So again, this constant is going to move to the other side. We're going to add the 18 over here. So now you have x squared plus 12x. We're going to complete the square on that quadratic, and then you added the 18 over here, and then we're going to balance out our equation with the blank over there as well. So same idea, you take the b term, cut it in half, so that's 6. 6 squared is 36. And once you add it to both sides, you've balanced. Now the reason you use that formula and put a 36 there is because this quadratic factors into x plus 6 times another x plus 6. So we're going to shorthand that by saying x plus 6 quantity squared. And then it equals, oh gosh, I should be able to add this right, 454. I feel like I did that wrong. 54. Alright, so now we're square rooting both sides. And 54 does simplify, but not all the way like the previous question. So you have x plus 6 equals, I'm going to put down a plus or minus so I don't forget. So 54 can break into, what was I just thinking? 9 times 6. So this simplifies to 3. So it's like 3 squared to 6. And this is an irrational answer, so when you subtract the 6 to the other side, just leave it as negative 6, and then both add and subtract 3 squared to 6. So that question had a few layers of complication there. We had to simplify the radical. We had irrational answers, so we just kind of left them grouped together like that, and that sometimes does occur. Now, this is a newer topic for completing the square. We're going to use modified completing the square to write in vertex form. And you must show your steps, because I know there's other ways. And I like you to confirm these answers, but I want you to use this method. So the way the method works is you don't move anything to the other side of the equation this time. We're going to keep all of our work over here on the right side. So the x squared plus the 6x, what I want you to do is I want you to complete the square on that quadratic. Now this plus 5 just kind of got shoved off to the side. But here's the key difference, guys. When you add a blank right here, so you're adding it right here, to keep life balanced, if you also subtract the blank, everything is still balanced. So let's talk about what goes in the blank. You're completing the square on this quadratic. So half of b would be 3, 3 squared is 9. So here you're adding 9, and over here you're subtracting 9. So at first you guys learned this and you're like, well, why'd you do that? Well, because this quadratic is now factored into x plus 3 times x plus 3, or you can say x plus 3 quantity squared. And then right here, this little addition subtraction problem here, plus 5 minus 9 is a minus 4. So what you have now is vertex form. You have a quadratic in vertex form. If I asked you where the vertex is, you'd tell me it's at -3, -4. Now, if I was you, if I had extra time on my test, I would double check that this quadratic and this quadratic are indeed the same quadratic by graphing them both. Alright, so that's going to be a new score on an old topic, but it does have a new skill in there, that vertex form stuff. Alright, so this is another old topic. This time, I'm not going to give you guys any sort of skeletons for factoring. You have to know how to factor really well, and then you have to make sure you go through and you solve your factors. So looking for a common term first, I noticed that there's a common 8m that I could take out of the problem. It's a form of factoring. And if you take an 8m out of there, so it's like you're dividing by an 8m here and an 8m here, you're left with m minus 5. Now you haven't actually solved yet. You have a factor right here, and you have a secondary factor right here, and they both have to be set equal to 0. So if 8m equals 0, you get an answer of m equals 0. And if m minus 5 equals 0, you'd add the 5 over and you get m equals 5. So make sure you get both answers here and make sure you're factoring properly. I'm going to skip number 8. It's a lot like number 7. And let's look at number 9. So there's no common factor this time. So this is our traditional trinomial factoring, where you factor, factor, factor. Here we go. N times n will be n squared. And my last numbers have to multiply to -12. So 4, 3, 6, and 2, 12, and 1. If I kind of look ahead in the puzzle, I think we're going to use a 6 and a 2. And if you use a -6 and a +2, those arches will add up to -4 in the middle. Now you're not done. This is where you need to take each factor, so this factor and this factor, and you need to set them equal to 0 to solve. So if n minus 6 equals 0, that means n equals 6 when you solve it. And if n plus 2 equals 0, that means n equals -2 when you solve that one. Alright, moving along. A little more complicated factoring coming up. Let's look at number 13. No common factor, but this is that funny difference of squares pattern. This is that a squared minus b squared pattern where you take the square root of each, and then you make the good twin evil twin pattern, we call it sometimes, 1 plus and 1 minus. So the square root of 25p squared would be 5p. And then the square root of 64 would be an 8 and an 8. And then if one's a plus and one's a minus, that's how the middle terms canceled out to nothing. There's nothing in the middle. Now, careful here, guys. You're going to take each factor, so here's your first factor, 5p plus 8 equals 0, and you're going to solve it. So you're going to subtract 8, and then divide by 5, and I'm running out of room, of course, so p equals -8 over 5. Some of you divided backwards last time, that was sad. And then when you set this factor equals 0, you get a very similar answer, but it's positive. So you're going to add the 8 over. So 5p equals 8, divide by 5, and p equals 8 over 5. So I need to see both of your answers, and I'm really hoping that some of you who struggled with this section last time, you have a better grasp as to what I'm asking you to do. So you're not only factoring, but then you're solving your factors. Number 15 and 16 are still trinomials with no common factor, but these are the harder puzzles where you have to kind of think before you settle on your factors and really check your puzzle. So first terms have to multiply to 4b squared. I'm thinking it's going to be 4b and 1b. And the issue is I'm running into with the 6, but we'll see. Alright, so if we do -3 and -2, oh yeah, that'll work. What if we do a -3, nope, not there. -2 right there. I knew I couldn't put a 2 with the 4, huh? Oh, jeez. Now I'm doing it. -3, -2. There we go. If you check your arches here, guys, that's a -8 and a -3. And if you add -8 and a -3, you do get -11 in the middle. Now, I know that was kind of painful because you're like, oh my gosh, we're not even done. We didn't even solve yet. You have to make sure your factors are right before you solve. So set each of your factors equal to 0. So either 4b minus 3 could be 0, which means b equals, add the 3, divide by 4, 3 over 4. Or b minus 2 could be 0, so you add the 2 over and you get b equals 2. So either one of these answers, good answer. They're both good. You gotta have them both. Alright, so I'm hoping for a better score on that one. And guys, if the root of your problem is you're just not factoring right, then that's a problem. We gotta look into that. Alright, solve each quadratic through the quadratic formula. You need to know that the quadratic formula is the solution set of -b plus or minus square root of b squared minus 4ac all over 2a. Now, how you approach this on your calculator is kind of all the difference, because these aren't really hard questions. The first thing I notice about number 17, though, it's an equation where everything's divisible by 2. So I'm going to go ahead and divide everything by 2, so that way I don't have to divide later. So you end up with 2x squared plus 5x plus 2. That's my new quadratic. So your a value is 2, your b value is 5, and your c value is 2. Probably should have color-coded that. Let's see. 2 and 5, and then c is 2 as well. Alright, here we go. So your solutions through the quadratic formula are opposite of b. So positive 5, the opposite would be -5. And then your plus and minus square root of, instead of writing b squared, 5 squared, I'm just going to write 25. Minus 4 times a times c. So a was 2 and c was also 2. And then everything there, all of that's the numerator, it's being divided by 2 times a. So you need to kind of partially simplify this. And I'm going to take some workspace over here if you don't mind. So that -5 is still out in front. And then we have a plus or minus. I'm going to leave it under the radical here. But the discriminant, this stuff under here, this is what I want you to calculate. So that is 25 minus 16. So that's a 9 over 4. 2 times 2 is 4. Now, square root of 9 obviously reduces. The square root of 9 is the number 3. So, this is fun. We're going to get two answers here that are rational. -5 plus and minus, we just decided that's a 3, not a square root of 3, just 3, all over 4. So one of your answers is -5 plus 3 over 4, and the other answer is -5 minus 3 over 4. Now, we're still not out of the woods. Some of you are a little calculator happy and you don't like to do anything in your head. I understand, it's a test, but make sure you use parentheses around that numerator if you're doing this in your head. So that would be a -2 over 4, so that comes out to a -1/2. And then this is a -8 over 4, which is a -2. So x equals -1/2 and x equals -2 are your two solutions. Let's look ahead at number 19. Quadratic formula again. This time we are not lucky enough to have any sort of like common divisor. So we're going to set up who our a and b and c are. And it turns out a is -9. And b is -3, and c is a +16. So quadratic formula starts off with x equals, the opposite of b, in this case would be a +3, plus and minus, this big square root sign, and then instead of writing -3 squared, because a lot of kids mess that part up on the calculator, I'm just going to write 9. This number here is always squared, which means it's always a positive. Minus 4 times a times c. A was a -9 and c was a 16. Oh gosh, I'm going to be able to do that in my head? I don't know. And then 2 times a, which is -9. So in stages, you guys are going to calculate for me the discriminant, the stuff that's underneath the radical, And of course you can calculate the denominator a little simpler. So you have positive 3 plus and minus, oh boy, here we go. I give up, I need a calculator. Alright, 9 minus 4 times negative 9 times 16. Either do that all in one step, oh gross, or, I mean, you could try mental math, I just don't think that's a really great idea. You get 585. I'll tell you, on the test, they're not going to come out that disgusting, because now I have to decide if 585 is reduced, if it can be reduced, I should say. And I'm hoping the answer is no. Now, if I had the answer key in front of me, I'd be able to tell you that answer. Oh, snaps, it does reduce. All right, it's divisible by 9. So I was dividing it by different perfect squares. So 585 is the same thing as the square root of 9 times the square root of 65. All right, so here's what we have. You have 3 plus and minus. Square root of 9 is a 3, and then square root of 65 is just going to stay gross like that. And that's all over negative 18. And this would not be a good answer, because if you look at all of your coefficients, the 3, and the negative 18, they're all divisible by a 3. So if you were to divide each of these numbers by a 3, you'd get a 1, you'd get a 1, and you'd get a negative 6. So final answer set, and it's irrational, so you can leave it like this. 1 plus and minus, you don't have to put a 1 here, square root of 65, all over negative 6. That would be a good way to leave your answer. Yuck! Sorry about that question. That was really gross. Alright, they're going to come out a lot nicer on your test. Okay, we're simplifying radicals, square roots only, but with i's, because they have negative answers here. So when you break this up, you're going to break it up into 3 radicals if necessary. So you're going to put your perfect square first, you're going to put your negative 1 in the middle radical, and then your leftover, the part that doesn't reduce at the end. So when I look at negative 32, when I break that up into 3 radicals, the perfect square factor of 32 is 16, with a leftover 2. 16 times 2 is 32. Negative 1 in the middle. Now here's where we did it in that order. Square root of 16, better known as 4. Square root of negative 1 is what we call an I. And then square root of 2 doesn't do anything, so we just leave it as the square root of 2. That's your simplified answer right there. There's 3 more examples of that. I suggest you guys practice those. Some of you have a real tough time simplifying just basic square roots, so maybe go back to just practicing that for a while before you involve the I into it. All right, here you're adding 2 complex numbers together. So remember, a complex number is in the form a plus bi. So a real part plus an imaginary part. And when you're adding and subtracting, real parts can add with real parts. So you have a negative 4 plus an 8 for real parts. So negative 4 plus 8 is 4. And then for your imaginary parts, you have a negative 5i plus a 3i. So negative 5i plus 3i is negative 2i. And you're not done with your answer until you've written in what we call a plus bi form, which this is it. You can say 4 plus negative 2i. There's nothing wrong with that. It's just kind of weird. All right, when you look at 27, it's similar, except this time we're subtracting, so be careful. So you have a negative 3, and then we're subtracting a negative 8. So please don't have a mental breakdown here in your test, guys. Just use your calculator if you have to, but negative 3 minus negative 8 is really negative 3 plus 8, so that is a 5. All right, and then we have a negative 2i, but remember you're subtracting negative 4i. So negative 2i minus a negative 4i will become, this becomes a plus, right? So this is negative 2i plus 4i, which is positive 2i. So don't stop until your answer is in what we call a plus bi form. All right, so those are supposed to be really easy questions, and I don't know why every year some kid comes through and they FOIL and distribute these together, which is really wrong. They're thinking it was a multiplication question like we had on number 29, but the previous examples were just adding and subtracting like terms. This one, however, you do have to distribute. So you start by multiplying the 8 into each part of the second complex number. So 8 times negative 8 is negative 64. And then, let's see right here, 8 times negative 6i is negative 48i. Slow and steady wins the race here, guys. Ready? Middle term here, negative 5i multiplied by negative 8 is a positive 40i. And then negative 5i times negative 6i is a positive 30i squared. Now again, you're not done until your answer looks like this, a plus bi. So a couple of things to remember. You're going to be able to combine I plus I. And then the other thing we have to remember is that I squared is really just the number negative 1. So this right here, this I squared, is really 30 times negative 1. So think about that. You have a negative 64, and then you added these together, and you got, what, a negative 8i? And then right here, you have a plus 30 times a negative 1. So this number right here, 30 times negative 1, is really a minus 30. But wait, there's more. Now, you have two real numbers you need to collect together. So negative 64 and later on minus 30 is negative 94, and then minus 8i would come at the end. So multiplying is a little complicated because you have to distribute, you have to collect your like terms, you have to know that I squared is negative 1, and then you got to finally get me the final answer in a plus bi form. So again, slow and steady wins the race on those. Do not go through those without showing work. Alright, dividing. You can't have I in the denominator because I is a radical and it's not allowed. So you multiply by what's called the conjugate of the denominator. So instead of a plus bi, you're going to convert it to a minus bi. So your denominator here, negative 5 plus 4i, keep the negative 5, negative 5 minus 4i, keep the negative 5, but change the I term to an opposite sign, so plus 4i. But we know in fraction land, if you do it to the bottom of the fraction, you have to also do it to the top of the fraction. Okay, so in your numerator, you've got 8 times the number negative 5 plus 4i. So if you distribute that 8, you have a negative 40 plus 32i. Now the denominator looks like one of those horrible multiplying questions, but it works out kind of beautiful. Let's talk about why. When you multiply conjugates together, negative 5 times negative 5 is a 25. And then you have a negative 20i. But on the inside arch here, you have a plus 20i. So on conjugates, the outside insides end up canceling. And then negative 4i times positive 4i is a negative 16i squared. That does not cancel. But it does simplify. So these knock out. And this is really a negative 16 times a negative 1. So this term is really a positive 16, which you can combine with that 25. So right now, I really wish I had more room, I'm sorry. You have a negative 40 plus a 32i, but it's being divided by, instead of 25 plus 16, call that what it is, which is a 41. And then remember, I'm not done until my answer is in a plus bi form. So you're going to divide that 41 underneath each term separately. So negative 40 divided by 41 plus 32 divided by 41 times I. So a plus bi. Gross, 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 gross. But that's the answer that they're looking for. Alright, I think we can sneak one more in. I have time for that. So the conjugate to negative 2 plus 7i would be, keep the negative 2, but now it's minus 7i. Multiply that by the numerator as well. So the first issue here is understanding that you need the conjugate of the denominator. And then you kind of go to town multiplying these together. So the numerator, we're going to distribute this time a 2i, to everything. So you have, oh boy, negative 4i minus 14i times I, so I squared. We'll come back to simplifying that in a minute, guys. This denominator, this guy here, conjugates multiplied together work out kind of nice. You get a positive 4. And then I have a plus 14i and a minus 14i, so I know those are going to cancel. And then a minus 49i squared. Alright, so now it's time to have fun with combining like terms. These are going to knock out. And all these I squareds that we see are going to change for a negative 1. So we have a little work on the numerator to do as well. You have negative 4i and then a minus 14 times negative 1, right? So this is really a plus 14. So you have a negative 4i and then a plus 14. We'll come back to that order in a minute. Divided by this negative 49 times negative 1. This becomes a plus 49. So this 4 is added to the 49 and you get a 53. But no teacher's going to like that answer because your teacher told you you want a plus bi form. So the first thing I need to do is reverse the order here. And then I also need to remember that everybody here is going to be divided by the 53. So final answer is 14 over 53. And then instead of plus a negative 4, I'm going to say minus 4 over 53i. That's how you're going to get the answer on the back, on the answer key there. Oh boy. Alright, good luck guys. There's some tricky stuff here. Make sure you're showing lots of work and steps so I can give you feedback if something goes wrong in your test. And I know complex numbers are new and unusual, but it's part of math. We gotta live and learn. Alright, good luck.